Okay. Okay. Fine. So we are going to see something. I've already shared the screen with you. That is how we are going to implement machine learning, but we have to see the steps also, how we start with the machine learning algorithms one by one. We have to see all of them. Okay. So let me share that. Okay. So there are a few steps, although it depends on you how you want to do. But these are the five steps you can say. Define the problem. You have to define exactly what you want to do. I always tell my students that why, what, and how. If you know of anything, you can do that. Why, what, and how. Why you want to do something, what you have to do, and how you're going to do is the last thing you can implementation. That is the implementation part. So if you are very clear about what exactly your goals are, you can always achieve them. It applies for everything. Okay, it applies to everything, whether it is programming or whether it is your life. So why, what, and how, three things you can define and you can do that. So define the problem, exactly what you want to do. Objectives, we say. Then prepare the data. That is what I have been telling. That data is very important in machine learning, or in any case, in anything, data is very important, right? Then you have to evaluate the algorithm. When we say evaluate the algorithm, actually, you have to work on the algorithm and see how it is working. But before that, you should know its strengths and weaknesses, what it can do, what it cannot do. So if you try something on a big data and you're implementing that, let's say you have 1 lakh plus records, 1 GB record, you can say. 1 GB record is a huge data set. And you're implementing a machine learning algorithm, it will take 6 to 10 hours to classify. Now, you have implemented one algorithm, you are waiting for almost 10 hours. And when you see that the results are not good, then you have to try with the other parameters, or you have to try another uh, algorithm. That is a wastage of time, actually. So you should first do your homework about the models you have, or the languages you have, or the algorithms you have. That is why I gave you the assignment, which only one submitted, to check the advantages and disadvantages of machine learning algorithms. So I got only one response for that, and that is not good. Okay. Anyway, you have to learn, you have to see how to do the things. Then you have to improve the results. You have evaluated your algorithm. How can you improve the result? Now, this is interesting. What you can do, you have certain things like you can first you can start with the data. You can clean up the data. If you think that it is not clean, there's some noise. We call it noise, actually. Noise is a word which has come from image and signal processing. Okay, it has come from there. Noise is some extra thing which is there in the image, voice, or anything, but it has come into the text, the numerical data also. That is something which is foreign, which is not useful, is noise. So we call it noise. That is a technical term we always use, that you have to remove the noise. That means you have to clean up the data, what is not required, what is suppose your data is not having the same data type. Some are integers, some are floats, or they may not be of the same width, size. Okay, like you have a float with 6 decimal places, somewhere where you are having 10 decimal places, somewhere you are having only 2. So you have to actually work on that also, and you have to streamline that. That is why we have the benchmark data sets which are fine tuned to the algorithm. So you have to fine tune your algorithm, data, in such a way that it fits the algorithm, right? So what you can do is you can arrange your data in such a way that only 2 decimal places are taken for all the data. So that will, or even if it is an integer, it converts into a float. upload 32 for 64-bit, whatever you want to do, you can have. You can try and test key if it is good with 32-bit or 64-bit. That is not. But for testing, we normally don't take a big data set. What I'll do is I'll take somewhere around 100 200 records. That's all, and then I'll test on that and test and see that okay, variety of data I'll have and see that which algorithm is performing well, or my one algorithm which I'm using, suppose I'm using decision tree or random forest, so I just test that on that particular data set. Okay, so if I find that okay, this is fine, then I can go ahead and implement on the bigger data set. I can fine tune my algorithm and the data. Now, data I have told you how we can fine tune it. We can see the data types, and also we have to see that it doesn't work. Algorithms don't work on strings directly. So strings, that is your characters. You have your you have alphanumeric things or something like that. You have alphanumeric is number plus integer. Okay, that is n101 is alphanumeric, right? So what we have here is if you have only strings or alphanumeric, you have to convert it into integers. Tokenization, vectorization. It's called vectorization. You have to convert a word to vectors or sentence to vectors, numbers. Okay, so we have to convert that. For that, you don't have to worry. We have tools to do that. So most of the things are done by using the tools, the models, the modules we have. We can use the modules and we can do that. So data cleaning is one part, and fine tuning fine tuning data tuning is one part, and second part is fine tuning your algorithm with different parameters. You can change the parameters and see. In deep learning, you have more options. In the machine learning, you don't have much. But what you can do is you can increase or decrease your training set and testing set and check. So normally, what I would do is I'll take a small data set, one, or I'll take a benchmark data set. I'll take a benchmark data set which is similar to the data set I want to test on. So if I take a benchmark data set, I'll show you today also a few things if I can, if I have the time. I think we should have enough time to see some implementation, and then you can see the behavior. So what first thing you have to do is clean the data and then fine tune the model you're using. So whatever machine learning algorithm you're using, you just fine tune that with parameters. Change the parameters and see what happens. One thing you can always do is training set and testing set. You can manage your training set and testing set. If you're using 2080, you can try with 3070 or 1090. 1090 nobody uses actually, but because it will be almost the same data set, so your accuracy will be very high. But 2080, 3070, that is the standard we use. Okay, so you can improve the results like that. And then comes the presentation of the results. That is, presentation is your plotting basically. How you can plot the results and see that how it works, right? So you can have the plotting. So 5 things: define your problem, prepare the data, evaluate the algorithms, then improve the results and present the result. These are the 5 steps you have to follow, right? Not necessary always, but these are the things you have. You don't, it's not linear as already written that okay, one by one step after the other you have to do. It can be your choice of doing the things, but defining a problem, preparing the data, these are some few steps you should follow to implement what you want to do to get the desired results. This is required. Okay, now let's see few things. 1 minute. I have the data. I'll show you some plots. Uh, First, I have to import pandas. Tools, I have already shown you that the tools we require. Pandas as PD. and import matplotlib matplotlib.pyplot है dot py plot. It normally comes as PLT. Let me first check this. I normally run the command and see that the modules are there and the syntax is okay or not. There may be some spelling mistakes sometimes. So I normally check them first. And first implementation in Collab is always slow, so I do that for that reason also. So let us wait for a few minutes, few seconds rather. It won't take long. It sets up. So okay, fine. Now it's okay. So everything is fine. Now I can take a data. Okay, and I have for this RAM prices I have. So let me import that. Let me put it here, uploading the data. You have to upload the data, keep that in mind. Without uploading the data, things may not work if I'm using some data, external data source. Otherwise, I have options to import also. Modules we have, like 1 minute, let me show you. Like we have a few data sets already here. I can use this also. But I'm using external data, so I'll be using this, and let me find the path for my data set. I have different places where I keep my data sets. So for this, I have it here. Let me take this one, RAM price. Okay. Oh yeah. It tells you that upload file will get deleted with this runtime is recycled. Once it is recycled, so if you share with me, I won't be able to see the CSV file. What I'll do is I'll upload it at GitHub and you can download from there. So I'll be uploading the datasets also. Now I have to read it, so I'm using RP, a variable RP to read the file, to store the data in that. So pandas dot read, we have read CSV. Okay, so read CSV, and in this RAM underscore price dot XLSX, I think it is XLSX. Check it. No, it is CSV. I can use the CSV file directly, not an issue at all. I can use XLX file also, but this is a price dot CSV file. That's okay. Doesn't matter. Now plot. We have to plot plt dot semi logi. That is logger. It uses log of the data. Logi rp dot date. It has the 1 minute. I have not shown you the data. Let me show you the data. And rp dot price. Let me show you the data first. It has date and the price. Okay, so RAM on particular date, it is actually here. What was the price? This is too high. This data is actually not right. These are okay. It was high, and that's okay. Doesn't matter. It's just for the sake of example. So we'll see. Okay. Now RP, we have to use RP, the handle we have created to read RP dot price. Let me check. It is price only. It is price only. It's not prices, so it is price. Okay. 1 minute. Now I can use directly plot also, but I'm using similarly. That is logarithm of the data I have. I want X label and the Y label. I'll just put this first. And this I'll put what I want to say. I want to say that this is year and this is your price per MB. MB. Okay. Let me first come into them, and then I'll show you what happens one by one. Close this. That will be after, so you don't have to worry. Okay, so you have the plot now, but you don't know what it is. So let's have the X label, where the X label will go. This is the year, so X label goes here, and then the Y label on the left hand side. This axis, Y axis. So this is the X axis and this is the Y axis. On Y axis, we have the price per MB. On X axis, we have the year. Okay, so you can have the data and you can plot. So that is how we can plot the data. We can simply use the data and PLT also, and then plot it. Okay, so different ways of doing things. All right, so let's go ahead now. You can try this if you want. Okay.
Can we have the file?
Sorry?
Can you upload the file?
I'll upload it. I'll upload it. I'll upload it. I can upload that. I can upload that here also. 1 minute. I can share it here. I'm uploading on files again. 1 minute. Okay, files. This will be on GitHub also. So for now, I'm uploading here. You can download from here. And I can upload if my GitHub is open. So let me see. GitHub is open or not. Yeah, it is already open. So I'll upload it there also. And I'll share the link for you. Link you already have, so you don't have to worry about that. RAM prices. I've not created any folder for that, so it will be in the root only. So RAM price or CSV file not be found. There's some error here. It is not loaded or what? There was no file. Oh, 1 minute. It's not open, so it should be saved. Okay. It is there, so it is there on GitHub also, so you can use it from there, and you can use, if you want, you can download from the file also. I have already shared it. Okay, so what we have to do is first of all, to implement you need scipy and all, but before that let me show you a few more things. Modules you have to install that we have already discussed. Okay, so you can download now. The file is there, you can download and you can test directly. Okay, so what you want to implement, it depends on that, but let me show you some few things which we have already seen that what is required. So 5 key libraries I'm putting here again. So this I think I have already given, but I'm just putting it here also so that you don't have to go back and see. The first is your scipy. This has to be installed. Rest are already there. Numpy, then matplot is already there. Pandas is there. sklearn also you'll have to install if required, but I think it is there. To check this, what you can do is import scipy and see. Just check it like this. Ankula, most of the things are there. Yeah, it is there. And then matplot we know, and pandas we know, numpy we know, and sklearn also should be there. Yeah, it is there. Fine. so you don't need to do it anything with this now. So these are the 5 key libraries you need, and if you are not using Colab, if you are using Jupyter or any other IDE, then you have to install them, right? So you can use pip install in the Python prompt also, and then install that. You can do that. Okay. So first thing is, as we said, that we have to load the data, and then we can work on that. Okay, so hello world is there. We have different data sets. So load data set. What I'll do is I'll put the path of the file. Although I have this with me, and this is a very common basic library, you can say data set which is used, that is iris data set. It is about the flower, petals and all. So it is there, so I'll be using that, and I can use the RAM price also, the same price, and show you how things will work. So let us see the modules you may be requiring. I'll just show you, and then we can run it also. I'll not implement as such. So these are the things you will be requiring. These are the pandas read CSV, pandas plotting, scatter matrix, matrix plot, then matplot. From sklearn, you need a train test split. This is when you want to divide your data set into training and testing, 80-20 or 70-30, whatever. So train test split module helps you in splitting the data. You don't have to do anything. It will split on its own. Just have to put train test split and the data inside it, and then it will split. You have to tell what is the percentage you want to split into, and then it will do that. So we will see that implementation, but these are the libraries you need to load. I just loaded all of them. Then cross validation score, that is the accuracy. And then you have models selections. We have the straight field 4, then classification report you want to have. Confusion matrix is something very interesting. Everyone wants to have a look at it sometimes or the other and see that how the classes are classified. I'll be showing you that also. Then we have the accuracy score also. Direct you can have a matrix so from that. And then we have some models. So for installing a model, you have sklearn dot linear model import logistic regression. From tree, you have decision tree. From neighbors, you have neighbor classifier. From discriminant analysis, you have linear discriminant analysis. And from Naive Bayes, you have Gaussian Naive, and from sklearn, you have SVC. And forest also we have random forest also, but these are the basic things, just telling you how we import. This is how we use. One by one we'll be using, not all of them at the same time. And the data set also we will be seeing how we can load. So we will see that how we can load the data set. First, let's see, load the data set. Okay, you can have different ways of doing that. So how to load data sets, different options use. Okay, so I'm using this. I have already a URL, so I'll be using that. And I'll show you. This we have already done already. Also, that we have read the data from the URL. Okay, so this is a data set that is iris.csv. I already have the file with me, iris.csv, but I have loaded it from a repository that is on GitHub. Okay, so from there you can use. So in the Colab it is helpful actually, because once I restart the dataset course, like in the previous case, now I can since I have uploaded my file, this is RAM price in GitHub, so now I can read it from there also. I can give the URL and you can read it from there. But since I've not done it, so it's okay. I'll just show you how it can be done. So you can use your path of the CSV file and just give it in the URL and just read it. Okay, now why I need names here, because these are the column heads. Okay, names here are the column heads, name of the columns. Like we have in this case sepal length, sepal width, then petal length, petal width, and the class. This is all you have, and I am giving this to read my data set, read CSV URL and the names. So this is going to read it, and let us see what we can do with this. First, let's read it. Okay, so it is giving some error. Read.csv is not defined. Read.csv is not defined because I have not actually run this module. Okay, let me run it first. So every library is loaded, although it is not required. Not all the things are required, and that's okay. Read.csv actually pd.cs read.csv I could have used like this one. I could have used pd.read.csv, but if I'm giving read.csv directly here, so I don't have to pandas import read.csv, then I can use directly read.csv. Okay, but pandas was only used for this purpose, so nothing else is imported. So you can read the data. Now what we have to now see is the data. You have to summarize the data. Okay, so let's summarize it. Okay, summarize the data set. No data set. Summarize your data set. Summarization is to be done. Let's see that. Okay. You have to see the dimensions, the peaks. First is the dimension of the data set. Shape you can see. Okay. Peak of the data set. Statistical summary. That is very simple actually. In Python, you don't have to do anything. You have commands for everything. But you should know what you have to do. Step by step, I'm just telling you what we have to do. Implementation will be doing. So first thing is the shape. So dimension is the shape, the dimension of the data dot shape. We have done the shape command data set. It is data set, not data. So data, that is why it is giving me error also. Data set dot shape. Okay, I can choose from there and let's print it. It will give me the rows and the columns. 150 by 5, you can see that 5 columns are there. Sepal length, width, petal length, petal width, and the class. To which class it belongs to. This dataset actually, iris dataset is the dataset of the leaves, the petals. Okay, so it is of that, and I'll show you what it is later. Now we have to find the peak. So let's see. Okay, the peak of the data set. In this case, actually, just have to find the heads. I just want to see what the data looks like, so I can print data set dot head. I can do it like this. It will give me just a few first five rows, or I can find more using the numbers here. Okay, so I can change the numbers and see how much data we have. We can increase it, decrease it, whatever we want to do. See your choice. Okay, so you can see that the class is still the same. So class has not changed till 40. So it has the indexing is from 0, so it is 0 to 39. So you can see the data set. Okay, now so peak we have seen, that is the data basically. Then the summary of the data set. This is interesting, summarize data set, or you can say that is your statistical summary. Okay, again we have a command for that. Print data set dot summarize or describe. Use describe command to summarize your data set. This describe will tell you that how many counts are there for each labels, each heads, each column, you can say. Then mean, standard deviation, minimum value, 25%, 50%, 75%, and maximum value you have. So it divides actually. So the scale, that is in centimeters, it is your numerical values are 0 to 8 centimeters. So this is what it is giving you, the length actually. Now we have to see the class. You have to see what is the class distribution. That is where you have to fine tune your data set. The class distribution, you have to again simple. You have print data set. But you have to find the group by command we have, and we have this one. Let me go up. We have class, group by class. Okay. And we have to find the size. You have to find the size, so you have to find how it is distributed. So it is equal distribution of the classes. There are three classes: Iris setosa, versicolor, and virginica. These are the different varieties of flower. So you have the class. You can always summarize your data set like this: data set dot group by, and in quotes you have to give the name of the head or the name of the column head you want to summarize the data on, like petal length, petal width. You can summarize on that also. Class, if you have given the class, and the size, that is it counts how many uh, data, how much data is there in it. Okay, individual elements are there, so it finds that. Now we can run it. Now complete thing we can do is we already have this data set to describe. You can put it in one particular thing and just do the printing part. Then comes your data visualization. That is the fourth one, is data visualization. I could put everything here in one code also, but that's okay. One by one we can see data visualization. Then in this we have first is the universal. I'm putting it here only. Okay, so we can have something like box plot. This is a very common plot. Labels, for the labels we can put so what we can do is box and whisker plot. We can have box and whisker plot. We'll see the plotting separately. That set dot plot. So matplot, I'll be showing you that. So but for now, just for the sake of example, what kind I want is the box plot. Type or kind, we use kind. Subplot equal to true, and maybe having some subplots. layout is some error. Let me see. Sub plots is okay. Oh, sorry. There's a minus sign. It gives you error. That is the best part with collab. So you know that you're doing something wrong. Layout is equal to, I'll have 2 by 2. You can experiment with other things. And share x, that is x-axis, is equal to false. That means it will go on the y-axis. And share y also false, so it won't go there also. Share s is small. Share y is equal to false, false, false. So it will decide on its own where it is going to go. Plot. Okay, so we have 4 classes, so it is going to plot accordingly. Okay, you can see that sepal length and all. You can see that we have sepal length, sepal width, petal length, and petal width. This is what was there. 4 parameters were there, and we had 5th one was the class. So you can see this. Now this is actually the line in between is the mean value. This is the mean value. It is there, and you can adjust with that. I'll be taking matplot separately, the plotting part, because this is data visualization is very, very important. So that I'll be taking separately. In the lab I can take, or in the next class also I can take. So that is important. I'll be explaining everything, how the plots are there, what type of plots we have, how many plots we can draw, because data visualization is very important. How you present your data, that is important. Even if you find the results and all, but you are not presenting them properly, then it is of no use. Okay, so this is there. I can have a histogram plot also. So I can have a histogram. So 2 type of plots I can have for now. The histogram plot, I have set.hist. We have parameters with this also, but for now I'm just doing that. And pyplot. In this case, I have to show actually. The previous one, I did not use it, but I needed that one there also. Pyplot dot show. I should have put it there also, but that's okay. I did not. Let me put it so that it does not confuse the things. Won't make any difference. But suppose it is not showing, then it will. So this is a histogram plot now. You can see this already arranged, right? Dataset.plot is already arranged. So we can have the histogram plot, the sepal length, sepal width, petal length, and petal width. It's simple, direct to give, and histogram it will take from the table, the data you have. So you don't have to worry about the titles or the headers. It will take one and so on. The only difference is here you have here beneath, here you are at the top, but the plot is also different. Okay, so 4 steps we have done. 4, yeah, 4 we have done already, and you can have multivariate plots also. Multivariate. This is scatter plot. That is why we call that a scatter matrix. Okay, so we can have something like I will be explaining that later. Scatter matrix. So we have scatter matrix. We have already imported that. I'll show you. हमने import किया था. Here you have this confusion matrix. Then यहाँ पे था कहाँ गया? Confusion. There was some plotting. Scatter, I think I called somewhere. It will tell me if I have not. Let me run it and check. If it is not there, then it will tell me that we have not called it. Matrices we are here, cross validation we have, confusion matrix we have. Let's see. I think it is already there. Sklearn हमने कॉल करा हुआ है तो scatter matrix should not be a problem. Scatter matrix that is there, and the data set and the pyplot dot show. PLT dot show also you can be using PLT. So you can see this. So different you can have the different plots you can have. It's a smaller version. It's not showing the things here. That's okay. So you can have a scatter plot also. So plotting is very strong here, and the relationship, it shows how closely they are related and what is the possibility that they are close together. Okay, now this we have done. Now we have to evaluate some algorithm. So we have one that we need a validation data set. So evaluate. Let me put the text. This is all visualization, summarization of the data. What we need is you have to do few things like separate out validation data set, one, then step up the test harness to use 10-fold cross validation. That depends on you, what exactly you want to do. I'll be taking that the technical part in detail, but I'm just showing you how it can be done. I'll explain the things. So first thing is create validation data set. One by one, step by step, I'm telling you. So you have to split the data set. I already have the code, so I can simply use that. And one thing I would like to tell you here, arrays dataset dot values. When I say values, it will just retrieve the values of the data. Okay, so data will go there. Then x-axis I'm having, and the y-axis I'm having some data. So before splitting this, let me show you one by one. Let me put them separately. Okay, so that you can see the data. Otherwise, you may get confused. Okay. What the data set would look like. Let me print this. So this is what we have. Now we don't have the headers. Labels are gone, and it is converted into a list. Multi-dimensional list you have. We can shape we have already seen, so we can have the shape if you want. Now data we are having. Let's see what we get here. Oh, I didn't print it. I need the actual labels and the data. X-axis is the data. Okay, this means all and 0 to 4. 0, 1, 2, 4. 0 to 4 columns, all the rows. This means all the rows, left hand side. Colon means all the rows, and 4 columns, 0 to 4. Look, 0, 1, 2, 3, 4. Fourth is not the last. So data you can see. It's not a big data, so I can actually show you. Otherwise, it would have been a difficult thing. I want now the rows names only. the class basically. You can see the class has come. Okay, this is the fourth one, the last one. All the rows with that. The fourth column, that is the last column. And now we split the data set. Let me explain this. X train and Y train. So X test and Y test, we have the data set ready. And now I can actually run the code. But since I don't have much time, so I'll just copy the complete code and run it for you. And then we can have the prediction. I'll just copy the entire thing. This is implementation. Okay, so model, we have used different models here. All the models we have called actually logistic regression, linear discriminant, k-neighbor, cart, naive Bayes, and SVM. All the models have been called, appended together, added together to give you some results like this. So what is the validation of what is the accuracy? It is basically calculating the accuracy. I'll be explaining them in detail. One by one, I'll be taking and just showing you how we find that and how we predict. So now I have to predict this. For prediction, the data set I have read again. This is where we left. X train, Y train. Model, we have used SVC here only. Gamma is auto, that I'll come to you. Then model.fit. This is where our implementation starts. Up until now, we were dividing the dataset and validating the dataset and checking how the dataset is. Here, this is what is the implementation. First is you have to call the model. Okay. I'll say call the model. Then we can compile the model. When I say compile, that means you're fitting it. Okay. So model.fit, extend and Y train, that is the data and the label. Then predict, this is prediction. And then you can find the validation score and the other scores. You can say precision, recall, F1 score and the support vector, the accuracy, macro average and the weighted average. You can see that it is 97%. That is very good. This is the confusion matrix which is created. This is accuracy score is very simple. You have accuracy score. We have already called that. Here we have already called. Okay. Accuracy score, confusion matrix and classification report we have already called. So in that we just have to pass on the data, that predicted data and the validation data. We have already created the validation data. So validation data and prediction, validation data and prediction is same on all of them. For the accuracy score, which is 96%, this one. This is the confusion matrix. When it is here uh, on this axis, if all the data is on this axis, okay, then you can say that it is 100% accurate, but one is out. You can see that is why it is not 100%. Okay, so you can see this, and then of each class, what is the accuracy score? Precision is 1%, and that means 100% accurate. This Virginica, this class is not actually classified properly. That is why your accuracy score has dropped to 97 or 95%, macro and the weighted average. For this, we have formulas to find the precision, recall, F1 score, and support. We have the formulas. I'll be telling you the formulas, how we can implement the formulas. This is one we have used SVC. We can use any other algorithm also. and this is actually just the plot of the default plot. That was of all the models, how accurate they are. That is, but this was not actually our aim. Our aim was this one, the last one. That was to see how we can use a prediction or how we can predict the data after compiling. So this is what happens when we implement any ML machine learning algorithm, right? So I have already shared the data with you. I'll be explaining the things again in detail, one by one, what the algorithm is all about. So until this place, this is okay. Now this part, actually, you can, for now, you can skip. You can go directly to the last part. You want to see, that's okay, but I have not explained it, so you can skip and come to this. This we have done already up till here, and this one is your model, calling the model, compiling the model, and predicting the model. Predicting the thing you want to predict. You want to see that the class is predicted accurately or not. So it is on the training set and the training set and the validation set. So training and the validation and the prediction gives you the results. Okay. So anyway, we'll be taking in depth further. So we will be continuing. Let me stop the recording. It's not required now.